Hello students. So far we studied about saturated hydrocarbons only. Now we will move to unsaturated hydrocarbons, and in this series we will first study about alkenes, which are the first class of unsaturated hydrocarbons and they contain carbon-carbon double bond. We'll have a general introduction about alkenes in this video, their structure, their hybridization, and also we'll see the different type of isomerism shown by alkenes. So let's start. Alkenes. Alkenes are the unsaturated hydrocarbons which contain at least one carbon-carbon double bond, and they are known as olefins because they are oil forming. The general formula for alkenes is CnH2n. Actually, let's write down the structure of first member of the alkene series. Okay, in case of alkanes, the series started from methane. The first member was methane. But in case of alkenes, as we know, there must be a double bond, and for formation of double bond, there must be at least two carbon atoms. So the series starts from the second member, that is ethene. The first member is actually ethene here with the formula C2H4, which is according to the general formula CnH2n. Next would be C3H6 and so on. Again, let's write down the structure of this ethene molecule, and it would be like this. Next thing is, they contain sp2 hybridized carbon atoms. That means those carbons which are double bonded have hybridization of sp2. So in case of ethene molecule, what we find, there are two carbon atoms and both are double bonded. So the hybridization for them would be sp2. And the angle between hydrogen, this carbon and carbon bonds would be flat 120 degree. And they contain both sigma and pi bonds. So if we see here, this is a sigma bond, another sigma, 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 and one pi bond. That means alkenes contain at least one pi bond. This is the orbital structure for ethene molecule. You can see that pi bonds are formed by sideways overlapping of the p orbitals of the two double bonded carbon atoms, while the sigma bond are formed between carbon atoms as well as carbon and hydrogen atoms. Next is isomerism in alkenes. Actually, alkenes do not show conformation as it was in case of alkanes. Why? Because conformation arises due to free rotation of the atoms along carbon-carbon single bond. But in case of alkenes, as there is a double bond and this double bond is not so free for the rotation, so they do not show conformations. They show two types of isomerism. One is structural isomerism, another one is geometrical isomerism, which is also known as stereoisomerism. So geometrical isomerism is again of two types in case of alkenes. The first is chain isomerism, then position isomerism, and then comes cis and trans isomerism. Let's discuss them one by one. The first isomerism is chain isomerism, and what happens in this case, that let's say this is the first member CH3. This is a member of alkene group CH double bond CH2. Okay, its name is 1, 2, 3, 4. So it is butene, or in more accurate way it is 1-butene. Okay, this is one structure. There is another possible structure for the same compound, and that would be like this: CH3, CH3, CH. Okay. In this case, there would not be a hydrogen atom here. It would be, yeah, it will not be. So this is the another possible structure for an alkene containing 4 carbon atoms, and the chemical formula for both of these is, yes, C4, 3, 6, 7, 8, 9. It is 8. And so is here 3, 3, 6 and 8. So both have similar formula, chemical formula, but difference is in their carbon skeleton. So such type of isomers are called, yes, chain isomers, which have different carbon chains. So this was butene, and this is actually, if I write the name of this, it would be 1, 2, 3. It would be, yes, it would be 2-methyl propene. It is 2-methyl propene. 2-methyl pro. So these two are the chain isomers of one another. So this type of isomerism is shown in alkenes, and which is known as chain isomerism. Now another type of isomerism was position isomerism. Now let's say this is a compound which is actually 1-butene. Now there is another possibility that the carbon bond, double bonds of the carbon come at this position rather than at first position. So the structure would be CH3 CH double bond CH CH2. This is 1-butene, this is 2-butene. So what is the difference between these two is that the position of carbon-carbon double bond. So these two are position isomers of each other. This is position isomerism. This is known as position isomerism, because in both of these compounds there is difference in position of carbon-carbon double bond, while these two are chain isomers. Chain isomers. So these are the two type of structural isomers possible in case of alkenes, chain isomers and position isomers. Now another type of isomerism which we discussed in case of alkenes was geometrical isomerism or cis-trans isomerism. Now what is this? Let's say I have again butene CH3 CH2 CH double bond CH2, the butene. Now I can write it in two form actually. Okay, let's take it in the form of 2-butene rather than 1-butene. Yes, this is 2-butene and it would be CH3. Okay, this is 2-butene. Now what I can do, okay, just write this position and it would be C. Now there is one carbon atom attached to this hydrogen, and similarly one carbon atom attached to this hydrogen, and there is another CH3 group attached to this carbon and another this carbon. So I can write it in this form. Another way I can write it, and that would be C double bond C. Let's say H comes here, CH3 comes here, again CH3 comes here and H comes here. Now what is the difference between these two? These two are the structure of same compound 2-butene, but the difference is that in this one the similar groups are on the same side, while in this similar groups are on the opposite side. So this type of geometry is called trans geometry and this is cis geometry. So this type of isomerism is called cis-trans isomerism. If the similar type of groups approach to the carbon atoms from the same side, it is known as cis, and if they approach from the different side, opposite sides, it would be trans. So this was the cis-trans isomerism. Now let's try to solve some problems which were asked in IIT-JEE once, and it says this one: in ethylene dichloride there are 1 pi. So we have to find out the type and number of bonds present in ethylene dichloride. Okay, so what is the structure of ethylene dichloride? It would be, it is ethylene, 1 H here, 1 Cl here, let's say 1 Cl here, 1 H here. Now what can we see from this structure is that 1 sigma bond, another sigma, this is also sigma, this is also sigma, and there is 1 pi bond. So there is 1 pi bond and a total of 2, 4, 5 sigma bonds. So there is, let's see, 1 pi and 5 sigma. Yes. So A is the correct option here. Next is the compound 1,3-butadiene has. So in this question we have to find out the type of hybridizations of the carbon atoms present in compound 1,3-butadiene. So let's write down the structure of 1,3-butadiene. First write down the skeleton 4 and a double bond 1 and third position. It will be H, again H, another H, and then H2. Okay, this side also H2. So now let's find out the hybridization for every carbon. This is a double bonded carbon atom. It would be sp2 hybridized. Same is here, again double bonded sp2 hybridized. This is also double bonded sp2 hybridized, and this would also be sp2 hybridized. So there are 4 sp2 hybridized carbon atoms. So the correct option is it contains only sp2 hybridized carbon atoms. So students, now you know that alkenes are the unsaturated hydrocarbons which contain carbon-carbon double bond. And you also know that they show 2 types of isomerism, structural and stereo. And also you are aware of the geometry and hybridization of the carbon atom in alkene molecules. In next video, we will move to the methods used for preparation of alkenes. Keep watching.